Okay, in the past I've done several videos saying how you can use these dual H-bridge drivers to control the direction of a motor with a single control line, and it was pointed out to me by an E.P. Morris on YouTube after he watched my videos that there was an even easier way. I'm going to explain how these things work, but in the past I was using a state that this had where the output drivers go into an open state, and I was using a pull-up resistor. Well, there's also a state built into these called braking, and in that particular thing it becomes an inverter, and we're going to talk more about that, which means you don't need any resistors. This device right now is wired to control this motor with a single control line that you can hook to logic or whatever you want to reverse the motor. And to show that, I will go ahead and connect a 3-volt battery pack to this guy. Get the positive on the positive and the negative on the negative. And got a little lobe on the motor so you can see that it's spinning in that direction, and this is the control line. The chips do have internal pull-down resistors, so you don't have to connect this to low. It will do that, but if I connect it to high, you can see the motor runs the other direction, and I can reverse it. Besides that, if you didn't want to just reverse a single motor, you could actually hook a motor to this peg and then to ground or positive, and a motor to that peg and ground or positive. You can control two motors, basically turning one motor on, one motor off, all from a single control line. I'm going to do other videos on these dual H-bridge chips because they're so inexpensive, anywhere from 26 cents, depending on how many you buy, up to 88 cents if you buy a single one. Using them as oscillators, using them as latches. You can use them for all sorts of things, and the advantage is their outputs can drive up to 1.5 amps continuously and over 2 amps momentarily, so you can get a lot of power out of that from a logic level input. Okay, let's talk about the chip so you guys can understand what's going on. I've got a printout which is larger here to make it easier to see, but what I'm going to show you first on the back is the truth table. This is the thing that is hard to find online. Usually when you look at this chip, they're selling it just as a motor driver H-bridge, so they don't bother to explain to you the full truth table. And what this means is we have two inputs. It's a dual chip. We're going to be talking about just the upper half of this chip right now. In 1, in 2, and out 1 and out 2, okay? But both sides can be used for the same thing or different things, independent, whatever you want. So, if you have a high on both of the inputs, you now are in what they call the brake state, which means if you had a motor, it would cause the motor to lock up, not just turn the power off. It's a brake. So if it tried to freewheel or backspin, it could stop that from happening. And the way it does that is two highs on both inputs, input 1 and 2, is going to give you two lows on outputs 1 and 2. There's our invert state. Using that state, we don't have to use any pull-up resistors to do what I was going to go into. In the past, I was going off the logic, if you have two lows, both input 1 and input 2 are both low at the same time, then the output states go into what they call Z, but that's what that means is open circuit. And I was using the open circuit with a pull-up resistor to give me an inverter, which worked just fine, but it means you have to add a resistor. Whereas if we use the first state up here, we don't need the resistor, we have an inverter, because any other state that we put into this thing would invert that. We're going to get into that a little bit more. Let's go ahead and look at the drawing. So basically, again, in this case, the motor driver you just saw me demonstrate, I'm using this lower half, inputs 3 and 4 and outputs 3 and 4, to drive the motor, which you just saw running. So this is a normal H-bridge driver here, which means if I put high here, I'll get a high here. If I put low here, I'll get a low here. If I put a low there, I'll get a high there. In other words, it's going to reverse the voltage to the DC motor, and it's going to run opposite directions. So In order to control that, you have two control lines. To get it down to where you only need one control line, we need an inverted input on one of these. So let's go back up to the top one now. So on the top one, we're going to take input 1 and just tie it to V+. That's what this black line is showing there. And then we're going to take input 2, which is going to be our control line, and we're also going to bridge it to input 3 for the motor. So one control line is feeding both this upper H bridge and this lower H bridge. Now we already know we're going to have an inverted state back here. If both of these are high, let's go to our truth table again. If both of those inputs are high, both outputs will go low. So we've got one tied high, so anytime we make this control line high, we know that we're going to get a low right here. So let's take that low, because it's the opposite of the input, it's an inverter now, and let's bring that around to 4. So now, no matter what we do here, we will get the opposite here, and that's what we need. If this is high, this will be low, so that means we'll have a high and low. If this is low, this will be high, so we'll get a low high. So that's how we can control the motor direction with a single control line. And like I already stated, but I'll state it again, there are internal resistors built into this device which want to pull them low. Doesn't take much. We're talking logic levels here at the input. So you can leave this open and use a push button if you want to it, or you can go to your Arduino, or you can go to any number of different sensors or control circuits, whatever you want, to make this swing from low to high. Advantage of using this chip to drive your motor, of course, is it'll work anywhere from 2 volts up to 10 volts. The outputs can drive up to 1.5 amps, and they're very inexpensive and they're very small. So this is just a simplified version of the motor reverse control using an H-bridge chip. This works with almost any of them that look like this. It's been tested with the MX1508, the MX1616H, and what they like to sell as the L298n Mini. Basically, if you see a device that looks like this, it's probably going to work. The hardest part in doing this is trying to get the full logic truth table showing what happens on the inputs versus what happens on the outputs. Normally they only show you the input to output if you were using it to control a motor, so they don't show you all of the states. For example, they don't tell you that if both of these are high you get 2 lows. They simply say if both of these are high you're in brake mode. Well, what the hell does that mean? They don't tell you. You got to get the data sheet for the chips to actually get the full breakdown of what everything means, and then you can do all kinds of interesting things with this chip. Like I say, I'm going to do other videos showing you how to use these as oscillators. An audio oscillator, think about that. You only need half a chip to make an oscillator, since we have an inverter, and if each output can drive 1.5 amps, so let's see, 1.5 amps, and if you had the full 10 volt in, that means you've got a 15 watt driver if you connected it up to a speaker that could handle 15 watts. Of course, your other option, if you're using smaller speakers like I was when in my project for Vanishing Shadow, where I wanted it to beep, I used 1/2 of the chip to make the beep tone, and I used the other half of the channel as the gate to beep the tone, to turn it on and off. But I was driving a little teeny speaker, and if I hooked it direct, you'd burn up the speaker, so you have to put in an inline resistor to limit the amount of power going to the little speakers, because normally they're rated at 8 ohms and like less than half a watt. But interesting chip, more to come.